Today, here we are going to discuss the instruction format of computer architecture and organization subject. What indicate the instruction format and what are different types of instruction format. Now, what do you mean by instruction format? Here we have one address instruction format, two address instruction format, zero address instruction format. Here we have the different types of instruction format. Previously, what indicate the instruction format? Instruction format, it describes the internal structures or layout of bits of the instruction in the term of constituent part. What part it has and what a bit we have, what bit we are going to store, it indicated by the instruction format. Instruction format must include the opcode and address. Obviously, what are the instructions we have? It has the one opcode and address as per the discussion in previous lectures. Now we see the instructions format. What instruction format actually we have? We can observe here instruction format where we have the opcode, mode and address. Consider one example, add r1 comma r2. So it is a where we have in operand where we have the two registers and opcode indicate the add. Where add is a opcode, what types of mode and address of that particular bit. That's why it is indicated by an instruction is normally made up of combinations of operations code and some way specifying operand. That here operational code, what indicate the operational code and operand is very important. That means any instructions, what are the instructions we have? Suppose we have the add r1 comma r2. So it has the operand and opcode. So it is called as instructions. The instructions is again divided into different types. What are the instructions type? Here we can observe. What instruction type? Three address instructions. Add. What indicate the three address instructions? Where we are going to use the three registers. That's why it is called as a three address registers. Where you can observe here, add is the operand, r1, r2, r3 is the three registers where we are going to use. How operation is going to perform? Where we add the data of r2 and r3 and store the result in r1 registers. That is called as a three address instructions. Second types of instructions here we have, that is called as a add instructions or two address instructions, where we are going to use only the two registers only. What is indicate? Add, you can observe here, add r1 and r2 and result is stored in r1 registers. Third types of instructions, here we have one address instructions where we are going to use only the one registers. Add m. What happen here? Accumulator, AC indicate the accumulator. Accumulator is add with the register. What are the register? Here we have our memory location we have, and result is again stored in the accumulator. That's why it is called as a one address instructions. What indicated zero address instructions? Zero address instructions indicate what are the where we cannot use the any types of registers. It is just only the add instructions where we can observe the output operations TOS plus TOS minus 1 and the result is again stored in the TOS. TOS indicate the top of the stack. So these are the different types of registers here we have. So actually that what are the instructions we have? That instructions having its opcode and operand or address. The instructions, any instruction is divided into two parts. First part is called as a opcode and the second part is called as a operations. Now, one by one we are going to see the example. If we have the one instruction or expressions that is called as a plus b into c plus d, how we execute using the three address instructions. First we need to add a plus b. That's why here we can observe add r1 a plus b, and operation is executed a plus b and result is stored in the r1. So here we have add a plus b and the result is stored in r1. Now next step is to add the c plus d. How we execute? Add c plus d and result is stored in r2 registers. That means till now one result is stored in r1, second register result is stored in r2. The Third step is to multiply R1 into R2. Then here we require the mul instruction R1 into R2. You can observe mul R1 into R2 and the result is stored in the X. Okay, that is called as a. Now second types, here we have two address instructions. How we execute the two address instructions? Same as before in previous instructions. Here we have same expressions, x equals to a plus b into c plus d. Again we have to evaluate it with the help of two address instructions. How we evaluate? Before of that, first we need to add a plus b, c plus d. First step is to move, because here we are going to use only the two registers, so it need to move the a data in the registers R1. That's why here we are going to use the only two register. Next step, add b with the R1. What are the b register data we here we have, and the second data we have in the a register, we add with the b and add. Now again same operations, here we call c plus d. In third step, what we here observe, move what are the data contained in the C register stored in the R2 register, because till now we didn't use any R2 register, just here we have used only the R1 step 1 R1 registers for step 1 and step 2. Now here in step number 3, we need to store the register C data in the R2 registers. That's why here we use the R2 registers. Now fourth step is to add R2 register with the D, because one data is stored in the D and the second data is what are the C data is stored in the R2 registers. Now we need to multiply R1 into R2. Here you can observe multiply R1 into R2. Now one step is again required to store that data in X registers. That is called as a move. What are the result is stored in the R1 register, multiplication result, it is again stored in the X registers. Now third types, one address instructions. How we execute the one address instruction? Here you can observe a plus b, c plus d, same operations here we have, or same instructions here we have. We execute first step, load the data of a in an accumulator. That is first step. Same here we require add with the register. What are the accumulated data is contained is add with the register b. That means what are the b data is, what are the b data we have, that data is stored with the accumulator. That is called as add with the accumulator. Third step, again here we require stored in the T. What are the accumulated data we have? We need to clear that accumulator, because again we are going to use this for it used for the C plus D. That's why we need clean it. That's why what are the accumulated data we have, A plus B, it is stored in the register T. Now load C again. After that again we need to add AC plus D, and again here we one result in the T and multi with the AC accumulated. What are the accumulated data here we have, the accumulated data must be add with the T, and last is stored in the X register. What are the X data here we have, is accumulated data here we have, that need to store in the X registers. That is called as a instruction format using the one address. Now zero address instruction format. What indicate a zero address instruction format? Here we need to push operations, that is top of the stack. Second operation, again we need to for B, push B. Again we need to require to add what are the A and B here we have, we need to add with the top of the stack. Here we perform the A plus D. Now again we need to C, push C, again we need to push D, and again need to add top of the C plus D top of the stack, and it's stored in the, after that multiply C plus D into A plus D top of the stack, and it's stored in the X register. What are the top of the stack result here we have, TOS result here we have, it need to be stored in the X registers. That is called as a instructions format. So these are the zero address instruction format, one address instruction format, two address instruction format, three address instruction format. These are the different types of instruction format. Here you can observe 3 address, 2 address, 1 address, 0 address instruction format. Thank you.